I'm upset. I'm upset.
Yes.
All right, should be good to go, Joe.
Okay, welcome to our weather discussion for Friday, May 5th. This is our last weather discussion of the term. So we won't be back here until, way. We won't be back here until the Friday after Labor Day. So unless there's a tropical cyclone and you nerds want to get in here and talk about that. But I will be in one of those seats. I will be in one of those seats. I can guarantee you that. So this is definitely the last time I will lead the discussion until September. No jacket today. I had to run across campus and I dragged post around too, and that was bad. And it's pretty muggy out. So the dew point temperature was reported to be like 38. That can't possibly be right on a map that I'd seen earlier. So I'm waiting to see that when we look at the odds, because it was really muggy. And anyway, we're all done with lecture in 100. That feels good, but I'm a little too warm. Yeah, thank God. A little too warm, so the jacket's off, but I don't want you to think I've turned Jim Jordan on you. I'm going to only report facts. There's going to be real theories that underlie the connection between all those facts, and I will speak in intelligible, non-Jim related sort of words. Okay, so that's how we're going to talk. So here's the, and there's no scandals in my closet either, so we can guarantee you that. I'm way too boring for that. Here's the animation of the infrared from the last week. Now, we keep doing this, and it's been a great year to do it, because every week you have to recap what happened that prior week. It's only one way to do it, but it's a particularly illustrative way to do it this time, because we had the development of, remember last Friday we were talking about a couple of separate disturbances that were going to get their act together in the Ohio River Valley area and really turn into a major storm, and of course they did that. It's not a surprise that the forecast was right, but it was an incredibly intense upper level disturbance, for a while a quite intense low level disturbance, and so it was windy on both Saturday and Sunday to a degree that we don't usually get. Heavy snows in northern parts of our own state and Michigan and surrounding states, which is only going to contribute to the flood potential, which I think was finally mentioned today in national media. I hadn't seen that anywhere else. Maybe it was on CNN. Finally, they're talking about snow in the northern plains contributing to a substantial flood threat along the Mississippi, especially in Iowa. So I don't know if that's the state of the art or where it is now, but anyway, that's where we are. So it's been quite a year. We've had a cool spring. I don't know if that's borne out in the numbers, but it certainly is anecdotally. We have not really had more than that 1 week of temperatures in the 70s. So it hasn't felt warm and spring-like, distracting for students as they approach the end of the year. It's been really kind that way. Finals week will be different because it will be warm and pretty nice. But hopefully by then the cake is pretty much baked and you're either expecting a good result or you're baked, one or the other. But it's up to you by the long past the time, it's up to you by then. Okay, so here's the development of that cutoff. It was northern disturbance 1, southern disturbance 1, and they kind of put themselves together. This is long about Monday, I guess, or Sunday, really wrapped up tightly there. The cloudiness associated with this dissipated quickly on the satellite perspective, but the winds persisted. So it was windy all the way through the day on Monday. So, and that's just a testament to how difficult it is to get rid of vorticity. Once you get it there, it's really hard to get rid of vorticity. Not so hard to get rid of clouds, you just got to move the air up or down, especially down to get rid of it. So, really intense vortex.
With that wind, you heard about that dust storm down in Illinois?
Oh, very
interesting. There was a localized dust storm. Farmers had plowed their fields. It caused a huge pileup and a bunch of deaths on Interstate 55, about an hour northeast of St. Louis.
Yeah, how many people died?
I don't know.
More than a dozen, and it was 30 or more cars were involved.
Yeah.
Sangamon County, that's where Springfield is.
Yeah,
That's
very
Lincoln's
localized,
hometown.
yeah.
And yeah, it was exactly what you said, Pete. They didn't get, in fact, let's keep our eyes on that location, right about here, when we go through the simulation, the animation.
It's hard to see it on here. It was real localized.
No, you won't see the dust. I'm just saying you won't see that. None of the high clouds make it there. It didn't rain there very much. So it was plowed fields that were drying most of the weekend in the wind, not getting wetted by light rain or something. And then they just picked it up, and it was really bad news. And of course, this was, I think, mistakenly described as a climate change artifact. I think that's not right. It just didn't happen to rain there while a big storm developed in the near vicinity. And it's a spring storm that happens. But the dust there, that conjunction is rare enough that it was pretty scary. And unfortunately, some lives were lost. Okay, so let's now go to our more current depiction. And thanks for the weak animation. I mean the week-long.
It's a nice thing to just say about this before I come in. Wait a minute, we want the color.
Yeah, what is this, 1978? So here we are.
Amateur hour.
Yeah, Technicolor. This is the Ten Commandments version of the satellite. Widespread cloudiness over the southeast. We'll see how well or not that's organized. And then band across the central part of our own state, parts of Minnesota. And that is currently precipitating. We'll see that in the radar. And then there's this little thin band of clouds, which is also showing up in the radar as a thin band of light precipitation. Aside from that, it's really hard to see, over the continent anyway, any well-organized circulation systems. Offshore, though, there's a pretty decent one to the southeast of the Newfoundland. And then there's this one developing well to the east of Bermuda, which is right there, which looks even more impressive as a baroclinic leaf cloud in the infrared. But you can see the trailing rope cloud really nicely here in the middle of the Atlantic. Imagine being out there, you know, you're newly retired, you're out on your giant yacht, suddenly you see this rope cloud, you don't know anything about meteorology, you figure, why did I go sailing on the first thing I did in my retirement? That was dumb. So, I like to make up stories, as you can tell. And then, so that's an interesting storm. This one here is more intense and better developed. But a pretty nice day across much of the country. Clear skies across almost the whole North American continent, with those couple of exceptions. And so not so bad. And the temperatures aren't so bad either, as you can tell from outside where we are. Okay, so let's take a look at the radar composite. Yes, thank you. And here's where you can start to see where a couple of those features are somewhat organized. So here's one that looked a little better organized earlier this morning. The radar summary I brought into class this morning had this line looking even better than it did at the initial time, where it was right there in southern Alabama and Louisiana. And it just kind of dissipates, not for lack of coverage. This is just the actual dissipation of that band. And so probably some rumble through, you know, New Orleans this morning and then on toward Pensacola, but not Muscle Shoals, but not terrible severe convective weather. And then widespread light to moderate rain across parts of Alabama, the Atlanta area. And then some showers on the wake of that thing going across at Vicksburg, Mississippi. And then here's a line of showers that are across the northern part of our own state. They look better organized than at first glance. So there's really something to that organization. We'll try and determine if we can see that in any of the upper level charts. And then that thin line of clouds we saw across Montana, draped across Montana, almost from corner to corner, is actually precipitating. Maybe not reaching the ground, but it's precipitating. And spreads into South Dakota and parts of Nebraska. And then it's raining in Seattle, but it's May, so of course it is. And it looks as though there's an upper level circulation center right on the Idaho-Oregon border in about this location. It's Juniper Lake, Oregon. It's right about there. And was it May 3rd, 1968? They had a series of 5 days in a row where the temperature started out either 0 to 10 degrees Fahrenheit, ended up 79 to 88 in 1968. Imagine that? Caleb.
So in Montana, there's what appears to be like a mesolo. Is that what I'm looking at, right? Or
Oh, right here?
yeah.
Yeah, I don't know. Sometimes you can be fooled by the reflectivity in the cloud. It doesn't look like there's really anything there, but you know, maybe water vapor would be interesting to look at.
Yeah.
Maybe there's some little vortex there. Let's take a look at that.
Are you in the terrain there yet?
Juniper Lake?
Yeah.
Yeah, it's near the Mount Shasta volcano, but it's not really high, so it's a little bit odd. It's closer to the sort of Craters of the Moon monument there in Oregon. Okay, so here's our feature.
Yeah,
It doesn't
we
look
can definitely
like
see the
there's
one on
anything-
the Oregon-Idaho border.
Yeah, that vortex is clear, but you don't really see anything particularly along that line in Montana, which is interesting. But this whole flow is unusual in the sense that it's headed westward.
Yeah.
And so we're gonna have to see what that looks like at upper levels. It's a really deformed flow with a cyclone, obviously, on the southern portion of it, and then there must be some contorted ridge to the north. And I've already seen it, so I know that's the case, but it's really an interesting structure. Yeah, so that's a nice picture of this. Surprisingly, in a small regional map, it actually does a pretty good job of that for us. Okay, can we take a look at, here we're just on the radar reflectivity. Let's take a look at the surface map. First of all, we have to determine what's the dew point in and around here, because my collar is soaking wet, so it can't be 38.
42.
Wow.
But in the 50s in Iowa. That doesn't explain here.
It doesn't, I wasn't in Iowa, so I don't get that. So 42 degrees. I am really surprised. I thought it was going to be almost 50. Wow, that's a surprise. So, I'm fighting this stupid sinus infection. Maybe I have this heat inside me today that's just, I don't know. But anyway, that was not even a strong jog across campus. I was soaking wet. 42 degree dew point. Nice day, 71 over 42. Lower dew points in the drier air, in the warmer air to the south in the sunshine. In some locations, look at this, moderate rain at Wausau, 51 over 29. So that temperature can drop to probably to low 40s before it's all done. It's already done so at Green Bay. It's kind of just about the wet bulb temperature. And the same is true here in Lincoln.
Is that 29 dew point for real in Wausau?
Sorry?
Is that 29 dew point for real? It's raining and they got a 30-degree dew point depression
It
almost?
seems weird.
28.
Everything else is in the high 30s or 40s, so I don't know about this 29. This might be the Jim Jordan data point for today's lecture. And I'm going to defend it to the... So, yeah, that's interesting. I don't know about that. Okay, where else was it raining? South. Let's go to the south and see if we see anything interesting down there. Besides high dew points, New Orleans was just visited by a line of thunder showers, so it's 73 there, 75 further to the west for a dew point. So pretty muggy air, and all the way along the Texas Gulf Coast, the dew points are in the mid-70s. So this is soupy air, and we don't really want that near us, not yet. And it's muggier there than it is anywhere in the peninsula of Florida by at least 10 degrees dew point. So this is dew point central today. Okay, I think that's enough for the surface map. Let's go to 500 millibars. So look at that flow. This is 7 a.m. this morning. So here's the flow from the Gulf of Alaska. It's not quite zonal, sort of northwesterly, even though it looks straight northerly. And then rounds the base of the trough over Southern California, sort of Death Valley area, Arizona. And then big ridge. And it's broken over itself. So this is a wave breaking event that's occurred here at 500 millibars. So here's a low level, a cyclone in the geopotential height on the southern line of which, of course, is where our precipitation band is. So this is an anticyclonic wave break, and that's ushering in all this easterly flow. So westward directed flow from central Montana across Idaho, Washington State, and then it finally turns to straight southerly along the coast of British Columbia. So that's a really interesting, wildly deformed flow. But it sets us up for a nice week, because this means that the entire central part of Canada will not be cold in the underlying troposphere in the coming week. And that's what we've suffered from time after time this spring, is that we've been so proximate to the cold air in central Canada that any little northerly disturbance has dragged itself and kept us below normal for the time of year that we've been in. And then there's the deep trough off the Atlantic coast where we saw at least one of these disturbances. I think the one that's right about here was the best developed one. But none of them look like they're really going to continue to be substantial disturbances, and nothing substantial will really come of this except cloudiness and some rain, unfortunately. Maybe it'll reconnect to this and kind of spur something off the coast on the weekend. But the main thing is the big ridge that's broken over itself in central and northern Canada is going to preserve us from any really substantial cold air. Even at 500 millibars, you have to go all the way to the southern edge of the archipelago to get to minus 20 at 500 millibars. And that's really far north for that modestly cold air, because it's minus 22 at Green Bay. So the rest of the cold air is sequestered in the northern part of Canada. I don't think it makes much progress southward during the week. Let's see what this looks like at 300 millibars. I think it'll be closely repeated, but with the extra comment that we can make, which is the flow is quite weak. You got 110 knot maximum, ridging the northern edge of this broken wave that's broken all the way north of Hudson Bay. So that's only 110 knots for a polar jet. That's weak. And the flow in the northwesterly flow on the western side of the big trough that precedes the wave break is only 142 knots. And that is in the right position to dig this thing out further. So this isn't going to move eastward. This is probably going to dig southward and maybe even intensify as it moves southward. So I think this whole big ridgy structure in the central part of the U.S. and central part of North America stays there and becomes a big player. Let's see what we can see one level higher than this, 200 millibars, where I got a feeling we're going to see a whole different complexion. largely different. You don't see anything really up along the polar jet boundary at 200 millibars because it's all too high. We're into the lower stratosphere there. So that was all polar jet and weak polar jet. This is a combination perhaps of polar and subtropical jet. This is clearly, we didn't see it at 300 millibars, that's the subtropical jet, revving the whole thing with some positive vorticity over the domain. And then there's a combination of polar and subtropical jets with the feature on the east coast. But even at 200 millibars, you've got this anticyclonic wave break over Hudson Bay. Very interesting feature to see. In fact, can we go to 500 feet and look at the movie? Because I don't know how this evolved. I haven't been paying attention to that. Let's see. So this is last Friday. So we'll step forward there every 12 hours, of course. Here comes the wave that helps to develop, the southern wave, northern wave. We talked about this last week, develops the cutoff over the Great Lakes, and there it is. And then what happens next? So that was our weather over the weekend. Intervening ridge, deep cutoff off of the California coast, and then some progressive waves on the northern periphery. So go back one beat. I didn't really see where this anticyclone came in. That's a pre-existing anticyclone. Okay, so let's go forward now. This thing gets cut off over eastern Canada, and then here's the intervening anticyclone between these two cutoffs. This one gave us the weather on the weekend, and this one over the coast of California. Let's see what happens with more things invading from the north. Let's keep going. So these two, this thing retrogrades ever so slightly, this thing amplifies, and they connect. So that's how you get this broad anticyclonic feature in the central part of Canada by the time we meet this morning. Very interesting. Okay, so there's part retrogression and part amplification, and they meet in the middle over Hudson Bay. Now that sets the stage for where we are right now.
It's like a Salvador Dali 500 millibars.
Yeah, it really does. It does. If it were in colored contours or you did anything else different at random, it would look really interesting. You're right. And if somebody had said, you know, this is the last map you'd send to a class to analyze, because they'd say, what the hell is going on with this 35 knot easterly in southwestern Ontario? What's going on with that? And it would be confusing. You'd have to really be careful about drawing that. It wouldn't be a nice assignment. But it's the real world, and that's how it goes sometimes. Okay, can we look at 850? We have to see what it looks like at 850. So at 850, big ridge feature sitting right over Hudson Bay. This is the antithesis of the climatology of the cold season, which has a Hudson Bay low. So we got the complete photographic negative of that. And the temperatures are really, let's see, this is chilly air, minus 4.29. This is all warmer, very warm over the mountain west of Canada. And so, let's see, with the flow being clockwise, there's some cold advection with southeasterly flow over Saskatchewan. I mean, it's like some sort of a Wizard of Oz world, you know, it's just not straightforward, but it's discernible. And then there's this, the region of lower geopotential height over Nebraska and Kansas, and that's ushering in pretty decent warm advection, which I think will be the story for the weekend. So you're in the mid to low 20s at 850 over Texas, and then by the time you get to Iowa, it's 9 at Moline. And so this is pretty strong temperature contrast, modest winds, 10 to 15 knots at 850, a little stronger to the south. So if those winds pick up, the gradient intensifies as perhaps this cyclone might get a little more intense. The warm advection will pick up. So we don't suffer any threat, really, of seeing it get colder here, it doesn't appear. Only a little bit warmer, maybe a lot warmer as the weekend wears on. Okay, I think that's all I have for the current weather. Were you going to do a forecast, Patrick? Yeah. Okay, I knew you were going to talk about some of that stuff in Michigan, the snow. So.
Yeah.
Thanks. Oh, can I just do this?
Yep.
So it's been a great year, and it's time now to drop the pointer.
Can we start with the Michigan, the first map, please? So I'm going to talk about that Michigan snowfall event because I was up here saying this is not going to happen. These snowfall rates, you know, were unrealistic. So
do you want the website or one of the pictures?
we can do this one first. Yeah, if we could blow this image up, maybe ever so slightly. So this is a look at. It's a map of stations in the United States that have reported 27 inches of snow in May. Okay, So you can notice, here's mountains, right? This is probably not too uncommon. Here's the Michigan event, and it stands out like a sore thumb. It's the only event, and this is noted, east of 100 degrees west, which is like a straight north-south line in the middle of the country. So this is a one-day total, 27 inches of snow.
Wow.
So let's go to 2 days now. So this is now a look at stations that have reported 40 inches of snow in 2 days in May. This is pretty much the same map in the western United States. And then here's our Michigan event as well. 40 inches in 2 days. The 3-day snowfall event for this station was 48 inches of snow. So that's 12 inches, about 12 inches a day. It turns out that over 4 days, Herman, Michigan got 52 inches of snow from this event. And I was up here saying, no way, we saw 35 inches of snow. That's not gonna happen. I was spot on. We did not see 35 inches, we saw 52 inches of snow.
Crazy.
So this is a ridiculous event here, and we'll look at more UP Michigan snowfall totals here. But let's go to the website now, please, Pete. I took an HTML look at the snowfall event, and we can scroll down to the very bottom. This is National Weather Service in Marquette, and we'll notice, perfect, so here, and you can just scroll up ever so slightly. So we'll see, here's our snowfall event beginning to start, and I want you to watch the temperatures. So we'll see light rain, maybe fog mist. Here we might get some changeover. It's 38 degrees and snowing. If we keep going, we'll see 34. It's back up to 40. If we keep going, 34, 33, 34. And it's still snowing this entire time. 33, 32, 34. And then we finally stop the snow. It did not get below freezing in this entire look at this storm over at Marquette, which I think is pretty anomalous for northern Michigan, for a snowfall event to not get below freezing. It might be interesting to look at that. But because it didn't get below freezing, we'll go to my last image, please, Pete. And we'll look at the snow water equivalent. So the amount of liquid water in these snowfall totals. And this is a look at the entire UP. Okay, so we can see here's our list of snowfall totals. So we see ranging from 52 inches to 12 inches, and I'll read off some of these snow water equivalents. I wrote them down here. So Herman, Michigan, this is average of 6.5 to 1. So 6.5 inches of snow to 1 inch of liquid water. This one, Carlshend, is 4.2 inches of snow to 1 inch of liquid water. This one in Marquette is 5 inches of snow to 1 inch liquid water. And then Clarksburg and Ishpeming, these are 4 inches of snow to 1 inch liquid water. So imagine shoveling 52 inches of snow with a 6 to 1 ratio. That's gonna break your shovel and your back. You just gotta wait for that entire thing to melt.
It's concrete, it's like building a highway.
Yeah.
Yeah.
And then it's 60 degrees the next day, and it's perfectly sunny, yeah.
The Big Bay one, that's 2.5. That's a lot.
Yeah.
Oh, wow.
Is Big Bay, Wisconsin?
I
Is
don't know
that,
what that
is that, or is that in Michigan? Are they all in Michigan?
Which this is basically the closest you can get to rain, snowfall, pretty much.
incredible.
So,
That is incredible.
yeah, this was pretty crazy. And I remember this one-day event in Marquette. They got like 22.6 inches of snow or something. That broke the all-time May snowiest record. It was 1 day of snowfall. And that's all it took to break their all-time snowiest May. These locations have already seen their record snowfall. So this was 52 inches, 30 inches of snowfall on top of a record-setting season.
Man, unbelievable.
So yeah, you can imagine there'd be some flooding after this event. And it's going to get rainy, which I'll talk about later on. But I wanted to point this out, that I was exactly correct. Maybe there's one 35-inch snowfall, but that's it.
That's right where the most was that day.
Yeah.
Right, yeah.
And look at that
We-
snow pile in the picture. It looks like rubble.
Yeah.
It
Oh,
doesn't,
yeah.
doesn't look like snow, you know?
Yeah, no.
It's ugly. Wow.
It would be miserable to be
No
have to
kidding.
tread with this. So let's please go to the AOS QPF looker, or looper, please, Pete. And I'll show a look at the mean sea level pressure over the model run and the QPF, the amount of liquid water. Yes, please. And if we could just slow this down as much as possible, and we can just let it run forward. So first we can look at the colors. We'll show the QPF, the amount of liquid water forecast. So we can notice, we see a lot of the United States is in the gun for liquid precip. Turns out most of the United States, except for maybe Maine, Florida is pretty light precip, and then the desert Southwest. There's 2 bullseyes that will come up in Texas, and then into the Central Plains here, and maybe into Montana. So I'll let this loop through again. We can see that widespread precipitation for much of the United States. And then I want to focus on the contours. These are mean sea level pressure contours. And you'll notice it seems like there's a low pressure system that just sits over western Oklahoma, western Texas, and doesn't really move. And so we can talk about maybe why is that the case? Why is there this persistent low that sits here through this entire model loop? It varies in strength, but it largely just remains in that location. And as a function of that, you get flow, southerly flow off the Gulf, and you get precipitation that sort of makes a comma shape around that low pressure. And you can notice there's one little disturbance that I'll point out here that moves off of this low pressure sitting over here. And we get in the chance for some severe weather potentially on Sunday. But a lot of this just looks like rainfall for the most part.
Looks like it moves up the east coast, or the east side of the mountains right at the end. It kind of sits, like you said, over the Four Corners region the whole week. There's that little one that comes off over the weekends. And then as we get closer to the end, kind of right there, it starts moving.
Oh yeah, there we go. Yeah, might get some development. That's true.
And I think that's
Yeah, it looks like an anticyclone fills in behind.
Yeah,
right.
Pushes back.
So that's finally a development that takes.
But that takes all the way till
6
next
days,
Friday or
7 days.
something.
Yeah, that's pretty interesting.
Let's see. There it goes. So Friday, yeah, late Thursday, Friday. But we have this persistent low pressure just sitting. So it looks like a cloudy and potentially moist outlook for much of the United States. And so let's go to this same look, please, Pete, at 500. You can take a look at maybe why is this the case? Why is there that low pressure that just sits almost stagnant? We'll do the same thing. We'll just make it as slow as possible and let it move. Here, perfect. So I'll let it restart. And we can notice, here's our existing troughs that were off the west coast. You can see this trough sitting over the western United States largely doesn't move. So it stays in the same pretty much orientation. So we get one disturbance that maybe shifts its orientation.
That's the one that was northward, yeah.
Right, and this is that development, yep. That's the only thing that keeps this, or that advects this trough in the entire forecast. This little blip right here.
And when
Eventually it makes its way.
when that one gets out of the way, then there's a ridginess that fills in behind that.
Exactly.
It used to be like that, wasn't it? Because the thing cuts off over the Gulf of Alaska too. at the same time.
Exactly, yeah, there's this monster.
A lot of cutoffs.
That's right. But this little feature is the only thing that slightly shifts the trough towards the east, but then this feature right here is what forces the development out ahead of the trough, and then finally it advects it away from the western United States and ridginess fills in. But largely, troughiness over the western United States means large-scale synoptic ascent for much of the central and eastern United States, and that's what seems to be the case for this event. There's not a true development aside from maybe something right there, and then this system that brings a stronger low pressure to the northern states.
Yeah, and the interesting thing about putting a broad-scale persistent trough over the longitudes of about southern Nevada is that you also are, the westerly flow at the base of the trough is going across the high terrain, so that reinforces
Exactly right.
the lower tropospheric low in New Mexico and Arizona.
Exactly right, and we'll see that in the 850 temps as well. You get flow over the Rockies, almost perpendicular to the Rockies here.
Yeah.
And that's just going to adiabatic compression warming. And that's why that's one feature why we stay warm. We also have southerly flow at the surface, pretty persistent. So good sign for us to stay warm, but we'll stay pretty moist and cloudy and rainy, it looks like. So let's go to the same look, please, Pete, at 850. You can see that feature here. So this would be looking at 850 temperatures in the color fill, and then the lines are geopotential height. And I'll wait for this to restart here. There's that big Gulf of Alaska low. We can notice, so here's maybe some semblance of a trough, and here's our low at 850. That just is pretty persistent. And you can notice strong heating in the lee of the Rockies. You can notice the diurnal cycle, but this persists until we get that low pressure development and maybe some ushering of cold air from Canada. But largely, Central Plains and into the eastern United States remains warm at 850, which means we'll probably remain warm at the surface as well. And that's what it looks like likely. We'll be about 10 degrees Fahrenheit above average, it seems like, for this upcoming week until we get the shot of cold air right at the end there.
And Canada's devoid of cold air after about Sunday night. Look at it, just
Yeah,
gets
look at this.
eroded. Right at this point, there's nothing cold in all of the plains of Canada, in
Right.
the eastern provinces even. So we're preserved from any
Yeah.
incursion for quite some time because of that.
Yeah, look at that, at the very end. So it looks like there might be a signal for next week to even be a little warmer with that feature right at the end. But you're eroding all this snowpack up here. Temperatures have been in the 70s and 80s in the prairie provinces, so that's where our cold air largely comes from, and so that's a good sign for us to stay warm. Yeah, right there, forecast. That is all I had to look at. So are there any comments or questions about what I showed?
It's interesting, Patrick, that I never thought of it this way until this has been so vividly illustrated by this current forecast. Now, it's not observations yet,
Right.
but is it the evacuation or eradication of cold air in central Canada that really turns the screw for us to get into the spring, unmitigated spring and summer? Because I did this really interesting thing for another column we had to write a couple weekends ago. I might have told you all this. There's no single day since 1939, from June 11th to September 11th, 1939 to the present day, where the record low temperature is 0 degrees, or the record low temperature is 32 degrees or colder. That seems to me to be a perfect definition of summer,
Right.
June 11th to September 11th. And then from the 23rd of November until the 15th of March, there's no single day where there isn't a record low below 0. So that's a good definition of winter. And then you can put the spring and the fall on the other side of it.
Intermediate, yeah.
Yeah, and it makes me wonder if there's something related to this kind of warming of Canada that makes that sit in. Maybe on June 11th, the map of Canada looks a certain way and doesn't look different until September 11th, or something like that. You know what I mean?
I can believe it. Yeah, especially if you get the poleward shift of the jet that just stays
Yeah,
here and you
makes
just get
it-
constant heating.
And it can't
Altered
get
here.
cold there anymore, so it never
Right.
gets cold again.
Right. I believe it. Be interesting to look at.
Yeah.
Yeah.
So, and regionally, is it roughly the same? You know, because Minneapolis and us don't have the same day-to-day climate, but does that measure look about the same? I don't know. So.
Any other comments or questions?
Is it possible to see the volcano eruption in Guatemala?
Ooh, volcano erupting in Guatemala.
Look,
Is there a pretty big eruption going on?
So,
Good.
see like, CMW has done a forecast for, that sulfate dioxide, next few days.
Okay. Let's see if we can see that.
it would be down. It's the last 12 hours.
I don't see anything.
Probably do some special meso thing or something, to
Yeah.
finally catch on and put it up there. That'd be
Yeah, there might be a
interesting to see.
dust or a CO2 or something that I'm not
Yeah,
plotting.
there might be.
Guatemala, they don't need more disasters. Yeah, apparently we don't have anything readily available.
Yeah, unfortunately. But there might be something to watch. See where that ash goes. Maybe we'll see some stuff come up in the later.
Yeah, not yet, huh?
Who knows? That's interesting, something to watch though, for sure.
Yeah.
No satellite, well, maybe that. It's a still image, but maybe that's some remnant of a volcano erupting. But it looks pretty small, I don't know what this is showing.
Maybe just the site.
Yeah, that's true, might just be where the volcano is. Looks like that it hasn't updated yet. Maybe this is the plume? I don't know. That's kind of hard to see with all the clouds, but.
Yeah.
Interesting, yeah, something to watch.
Yeah.
All right, well, thank you,
All right.
Patrick and Pete,
Thanks.
thank you for both of you.
All right. Have a good summer, everybody.
Yeah.
Good luck on exams.
Hot tub.